Okay, we are working in the 2.4 section on continuity. We're looking at applying the laws of limits and the definition of continuity to solve some of these problems. So we are going to use just what I said, the definition of continuity and those properties to show that this function is continuous on this. So what you basically need to show is the key part, is that is it true that the limit of this function, all right, as x approaches some arbitrary number a, if that is the same thing as the actual function f of a. All right, so we're going to show that. We need to be clear about the interval over which we're talking, from -4 to +4, all right? And you have to think about this. Between this, there'll be some function that's doing something, and we can show the open interval from -4 to +4 by applying the limit laws and properties in the manner I will show you. So what we do is we take the function and we consider the limit of this function. I'm going to substitute it in here so I have room. And the limit of two things being multiplied is the same as the limit of these things being separate and then multiplied. So that's x times, well, I'm taking the limit of this radical. Again, one of our properties is that that's the same as the radical of the limit inside. And then I can separate these two things and have that be the limit as x approaches a of the fixed number, constant number 16, minus, and then the limit as x approaches a of x, and then squared. Okay? So this is just that process of breaking things apart and then looking at the individual parts. Well, the limit as x approaches a, if you go back one video ago, that's just going to be always equal to a. X gets closer and closer and closer to a, so the limit of x is a, times, and then the square root of, well, as x gets closer and closer to a, 16 stays 16. That's what constant means. Here, it's just like here. The limit as x approaches a of x is a, and then this is squared, all right? Well, lo and behold, that's exactly the same thing as if we just substitute in a up here. So this is equal to f of a. So that's the critical thing we're trying to show. Then all we really need to do is look at the endpoints and to see, are those in fact filled in? Well, when I plug in -4 into my function, I plug in -4, f of -4 is equal to 0. Well, that's the very value that if I consider the limit as I approach from this side, that's equal to the limit as x approaches -4 from the right. That limit is equal to 0. So these agree, and that means it's continuous from the right at -4. In the same exact fashion, I'll let you plug in the numbers, but if I plug in 4, I get 0. And if I take the limit as I approach from the left, I also get 0, just like that. And I can fill in this dot. And because it's continuous from the left and it's continuous from the right at each of these endpoints, we can then say that it is continuous on that closed interval that includes the endpoints -4 and 4. Okay? Wait. 5 plus the limit as x approaches +4 of 5 plus radical x over radical 5 plus x. Okay? So if I'm going to find the limit based on the fact that it's continuous, I need to look at the numerator and ask myself, what is the domain of this? Well, the domain of this will be the interval including 0 going up to infinity. The domain here is going to be from -5, which I can include up to infinity. I am considering the number 4, which is in each of these domains, so I do not have a problem with division by 0. You need to know your 8 or so functions that are found in our text in this section 2.4. Which of these functions are continuous over their given domain? Polynomials, rational functions, root functions, trigonometric functions, inverse trig functions, exponential functions, and logarithmic functions. In this case, we have a root function, so we know it is continuous. So all I need to do is substitute in 4, because it's within my combined quotient interval, which is the lesser, the more restrictive of these two. Right here. And so I plug in 4, and I get 5 plus the square root of 4 over the square root of 5 plus 4, which equals 5 plus 2 over the square root of 9, so 7/3. That is finding the limit based on the application of the laws of continuity. Okay, so that'll help you finish up the homework, and then we'll move on to infinity and beyond.